Hey guys, I'm glad you're here. My friend Roshan and I are having a big argument. I asked Roshan to buy a toy for my cousin. He brought her a doll. But my cousin doesn't like playing with dolls. Roshan says, aren't a toy and a doll both the same? No. A toy is more general than a doll. Not all toys are dolls, but most dolls can be toys. Moreover, dolls can be of different types, like a stuffed doll, a vintage doll, or an action figure type. Each of these toys are dolls, but they have different features and therefore have different names. The features that define an object are called its properties. This is similar to shapes in geometry. We know that a polygon with 4 sides is called a quadrilateral. Within the family of quadrilaterals, shapes have unique names: rhombus, parallelogram, square, and rectangle, to name a few. Each of these shapes have unique properties that make it different from the other. Knowing the properties of shapes can help us identify the shape and find unknown information. Let's see how. Here's a parallelogram. How can you tell? Because it is a quadrilateral formed by 2 sets of parallel lines. Let's explore more properties of a parallelogram. Recall that for parallel lines, the sum of co-interior angles is equal to 180 degrees. In the parallelogram ABCD, AD is parallel to BC and AB is the transversal. Angle A and B are on the same side of the transversal, or the co-interior angles. So, their sum is 180 degrees. Now, since angles A and B are also adjacent angles of the parallelogram, we can say that the sum of adjacent angles of a parallelogram is 180 degrees. Angle A plus angle B, or angle B and angle C, or angle C and angle D, or angle D and angle A, all add to 180 degrees. But what about opposite angles? The opposite angles in a parallelogram are equal. Why, you ask? Let's join the opposite vertices to make the diagonals AC. The pair of angles marked 3 and 7 are equal, since these are the alternate interior angles formed by parallel lines AD and BC and the transversal AC. Similarly, angles marked as 4 and 8 are also equal, because AB is parallel to CD and AC is the transversal. Adding both the pairs, we get angle C equals angle A. Angle A and angle C are opposite angles of the parallelogram, and we just concluded they are both equal. Similarly, angles B and D are opposite angles, so we can say they will be equal too. Today we have learned 2 important properties of a parallelogram. The sum of adjacent angles in a parallelogram is 180 degrees, and the opposite angles of a parallelogram are equal.